Dr. Christopher Exley is the Reader in Bioinorganic Chemistry at the Birchall Center, Keele University in Staffordshire, an honorary professor at the UHI Millennium Institute. He is a biologist at the University of Stirling with a PhD in the ecotoxicology of aluminium. His topic is a mechanism of toxicity of aluminium-based adjuvants.
Good morning, and I guess first things first, incredible gratitude to Al and Claire Dwoskin for organizing this fantastic meeting. We only have 45 minutes to save the world, so I'm going to get right on with my talk. And I am going to talk about my favorite element, aluminium. I'm going to give us some background to that, some of which I hope will help the following talks as well. So I haven't got time to dwell on any particular aspect because I want to give you a short story which is vaccine related. But clearly I am more than happy to talk to anybody about any part of it that we bring up today, or indeed anything to do with aluminium whatsoever. So I've called my talk this a mechanism of toxicity of aluminium-based adjuvants, perhaps a general mechanism of vaccine-induced injury. So we have spent several days, people telling us in some detail that there are situations where vaccination produces adverse effects. There's no question about that. Perhaps what we now need to do is understand why. And clearly, as you know, the vast majority of clinically approved adjuvants used in vaccinations are aluminium-based. So that really means that the vast majority of vaccinations involve injecting aluminium into the recipient. So we already have a common factor, aluminium. I hope the next picture is going to come up. We didn't really need this. It's just me showing off. I actually found a picture of me I like. So who am I? I am a biologist, but through necessity, through having to understand my favorite subject, aluminium, I started work on aluminium in my honors thesis for my undergraduate degree, and I have done nothing else since. Sounds boring, it's a passion. It's something that I live and breathe. So in those 25 or so years, I've had to learn the chemistry I need to learn. I've been in a chemistry department now since 1992. But the chemistry of aluminium requires, I think, in many ways, the insight of a biologist, because if you don't see it in the bigger picture, you won't really understand it in terms of what we are, what life is. In fact, life is, of course, the bigger picture. So what do? We look at everything we can to do with aluminium, from how it gets out of the Earth's crust all the way through to whether or not, for example, in a vaccination or when it enters our brain, whether it has any biological effect, whether it produces any toxicity. This is the raison d'etre of much of what we do. It's what I call a biogeochemical cycle for aluminium. And really all we need to take from this is the Earth's crust. And the Earth's crust has been enormously successful in almost completely removing any transfer of the Earth's crust most abundant metal into the biosphere. So here is living things. Here is essentially the mineral component of the Earth's crust. It's made of aluminium, silicon, and oxygen. And throughout evolutionary time, or biochemical evolution, there has been virtually no transfer between this cycle and the biotic cycle. This little one here in red is the human intervention cycle, and in the late 19th century we developed methods to take aluminium out of its ores and to make aluminium metal. And that brought in what I write about the aluminium age. We now live in an age of aluminium. We used to have the Iron Age, the Copper Age, the Bronze Age. Today is unquestionably the aluminium age. I know I'm going quickly through these, but if I don't... Oh, I've done it wrong again. Come on. What's the underlying philosophy? Very quick story first. This is one of my heroes. My real hero is Huxley, because Huxley was Darwin's bulldog. But Darwin is also a hero because in the market town close to where my university is a place called Newcastle-under-Lyme. There is a registry office there where we go to register our weddings and other things. So my wife and I had to register our wedding there. And on the wall in that registry office is the registration certificate for Charles Darwin and Emma Wedgwood. So I always tell my students I aspire one day that someone will go in there and there'll be 2 wedding certificates on the wall, when I show how important aluminium really is. So that philosophy, I was asked as part of the Darwin celebrations 150 years since the publication of Origin of Species and 200 years since the birth of Darwin in 2009, to write something for Trends in Biochemical Sciences using a theory of natural selection to explain the essentiality or not of aluminium and silicon. And indeed, aluminium, being the most abundant metal in the Earth's crust, should actually be an essential metal. All other abundant metals are essential. Aluminium has no known role at all. It creates a paradox. Indeed, silicon almost has no known role at all either. So it's quite unusual, unless, of course, one thinks, well, they're together in the Earth's crust. Perhaps being together is their role. And that's what this is Chris's tree of life, rather than Darwin's tree of life. And that's what this rather complicated tree of life tries to say. Essentially, in the early biochemical evolution, aluminium played virtually no role whatsoever. But since the advent of man, and since our ability to remove it from its ores, since the arrival of the aluminium age, bless you, more and more aluminium is becoming what I call biologically available, to the extent that in every cell, in everyone's body here today, there is aluminium, at least a few atoms. And aluminium is incredibly biologically reactive. So there again is a paradox. Why would a metal which could partake in many biochemical functions if it had been involved in biochemical evolution, why has it none? Why is there also no evidence that it's been selected out of biochemical evolution? So are we now, only in the last, say, 100 or so years, are we now for the first time living in the presence of aluminium playing a role in biochemical evolution? If we are, then the precedents for that are not particularly good for life on Earth at the moment, because all other precedents of how something, a metal became essential or an element became essential, you know, when oxygen first arrived, oxygen was terrible. Oxygen created all sorts of problems for the Earth. But then those problems turned into signaling systems. They turned into ways of creating energy. Natural selection defined those processes. So natural selection is now working potentially on increased biologically available aluminium. This is the sort of slide which I normally spend about 3 hours talking about, until everybody's asleep usually. Oh, I've done it again. Come on. I haven't woken up properly yet. So why am I here? So here we have Jenner injecting his child. I have followed the adjuvant story without participating in it too avidly. And I wonder why now, because there is clearly so much to learn since we have been injecting aluminium into us in the form of adjuvants for 80 years. And I have missed here. I've missed a real opportunity. What this slide says is, we know that adjuvants work, and aluminium adjuvants are fantastically effective, but of paramount importance, cheap. This is why aluminium adjuvants are really the most popular. Yes, they're effective. Yes, somebody says they're completely safe, but they're very, very cheap. But how do they work? How do they work? So again, around 2008, 2009, 2010, you may have noticed quite a few papers being published in high-profile journals purporting to explain how alum, as it's often called, aluminium adjuvants work. I was quite a vocal critic of these papers because it was clear to me that while they were from the most eminent immunologists on the planet, that these people had no idea at all about the chemistry of aluminium, and they were largely completely wrong. So being a little forthright as I was, the editor of Trends in Immunology asked me, okay then, you write something and try and tell us, how do aluminium adjuvants actually work? This is a cartoon taken from the paper, and I'm just going to go through each part very, very quickly, and all we're going to get from that is actually how complicated potentially this is, and probably how little we still understand about it. The only thing I know is that those that purported to tell us how they do work are wrong, at least in part. So a little bit at a time. The first part, you see, once an aluminium adjuvant with associated antigen goes into the interstitial fluid, there are myriad ways in which it can then potentially interact. This is not a simple situation. I have managed to think of about 11 different possible ways in which an interaction can occur simply at the injection site. So this is a very potentially complex. It could actually be relatively simple because one reaction may predominate against all others. But we don't actually know which one that might be. And in terms of understanding aluminium chemistry, and aluminium chemistry with respect to its potential toxicity, the only thing that we know about, which is hard, is that the Al3+ ion is the reactive form of aluminium. So all other aspects, all other 10 possible combinations of things going on here, at least those involving aluminium, may only serve to take Al3+ to a potential target site. That may not be the case. But with the information we have at the moment, that is all that we can actually possibly know for sure, that Al3+ is what is reacting with any biological ligand. So you then have, of course, many possible cells which can undergo any of the interactions with those different components, from macrophage-like cells into the muscle tissue. So there are a number of possible reactions and possible ways in which this reaction, which we just take for granted, you can see it's working quite well on me, this adjuvant response from a nice insect that I met on the beach. That reaction has myriad ways of proceeding once it's in the body. The types of each one of those cell types can then undergo other types of reactions, whether it involves endocytosis, whether it involves the adjuvant material being taken inside cells, whether it involves reactions at surfaces. Some of these are known types of reactions, some of them are more hypothetical. If I was going to draw your attention to one, I would draw your attention to this one. This is I think, and I don't think this has any scientific proof at the moment, but amplification of signals is something we see throughout biological systems. And this would be some sort of method of potentially amplifying a signal where an adjuvant would be working distinct from, for example, Al3+. But again, it's just something to potentially highlight amongst many possible interactions. And finally, if we're in the lymph nodes or we're somewhere where we can have our antigen presenting cell, and the possible ways in which that can then interact with the B and the T cells. And finally, if I'm going to point out one thing from here, what about direct action? Again, there is plenty of good evidence, actually, that aluminium will act directly on both B and T cells to produce responses from them. Of course, it has to get there, and it has to be there in sufficient amounts to induce a biological response which is robust enough to produce a biological effect. All that aluminium that's sitting in all of our cells at this moment in time, a high proportion of it is actually involved in biochemistry right now, all of which is non-essential, some of which could be toxic, but a threshold is never reached. In other words, the body copes with it continuously, perhaps producing some little energy deficit, but generally the body copes. So, what about just some mechanisms that we can have some confidence about in the way in which aluminium might act? And again, this is where the problem starts, because most of the people telling us how aluminium adjuvants work think that an aluminium adjuvant is like uric acid, or it's like silica, it's like asbestos. It works in the same way. There is no evidence for that at all. In other words, when aluminium salts are phagocytosed within the cell, there is no evidence that they break open lysosomes, puncturing them and allowing things to come out, and therefore potentially activating things like the inflammasome and others. But that's the main method. They talk about toxicity. There is toxicity at the injection site, but it is not the prime way in which aluminium is acting. Don't worry about all this text, but it'll be something to read later. It's not just killing cells. We know that for certain, because there is so much data out there on aluminium toxicity in cell preparations, in vitro. There's nothing much, almost nothing, specifically on an adjuvant, but we know enough about aluminium to know how that mechanism of toxicity would work. However, Al3+, for example, could participate in some very well-known reactions. We all know that free radicals, reactive oxygen species, are involved in adjuvant activity. They are involved in potentiating the immune response. If you combine aluminium with that, and particularly as nearly all vaccine preparations are also contaminated with iron, aluminium and iron together produce a potentiation of the activity of reactive oxygen species, which can be a tenfold effect. Aluminium is a very powerful pro-oxidant. So where you've got signaling via any type of reactive oxygen species, that signaling will be enhanced or sometimes shut down by aluminium. Another area is extracellular ATP. ATP is the most important extracellular signaling molecule. Hopefully Jeff Bernstock and others will get the Nobel Prize for this soon. It seems to have been overlooked. Almost every signaling system uses an ATP receptor for extracellular ATP and its metabolites, such as ADP, AMP, adenosine, as a sort of fine gain on receptor activity. It's a beautiful system, but it's prone to being influenced by aluminium. We've shown that when aluminium ATP acts on a receptor instead of ATP or indeed magnesium ATP, you can get both potentiation of a response and sometimes you can get shut down of a response. But potentiation mostly because it's at lower levels of aluminium exposure. So that's another mechanism whereby aluminium adjuvant activity could be occurring. I think this is some of the most fascinating work. If I feed, and this paper was the first one, but there are now papers from this group, Isabella Scholl and colleagues, there are now papers that worked with human patients. But in this first paper, they essentially showed that you could more or less make anything, or an organism or an animal sensitive to anything, if you fed it with an aluminium antacid. So you can make it allergic to codfish by feeding it codfish and antacid preparations together. Now, how much antacid preparation are we using? Just as one example, both from the youngest of the young all the way through our lives. What is the potential then to create sensitization to products which no one would even believe could produce an allergic or an inflammatory or even an immune response to? So it's very interesting work. Sensitization simply because of the co-localization or things being together at a particular time. It's excessive, of course. It means you've got quite a lot of antacid with the codfish to produce this response, but it is possible to induce sensitization. And aluminium, why are we surprised? It's such a fantastic adjuvant. It will do that, won't it? We know it does that. It produces sensitization at the injection site and other places. We shouldn't be surprised. Should we be surprised by this? Aluminium is an antigen. Now, when I went to school, we were told that antigens were proteins. But the more I read now, the more I realize that's not the case. The paper just came out in JBC last week showing that various carbohydrates produced antigen responses. So you can raise antibodies against aluminium, both protein-bound and free aluminium. And in fact, this group used that antibody, put a little fluorescent tag on it to quite beautifully show the presence of aluminium in human brain tissue. This group from Tel Aviv are one of the world's best groups making monoclonal and polyclonal antibodies. I was the editor who dealt with this paper. I sent it out to for most rigorous review because I didn't believe it. But no one can find any fault in this. And indeed, when you start to look a bit deeper in the literature, other papers have been produced for cadmium and for other metals too. So metals as antigens. It's interesting, isn't it? You've got an adjuvant which is an antigen. This is an unusual case that Roman and I have been involved with, of an individual who, following a series of vaccinations, went from being a very fit young man, photographer, who was going to work for the Ministry of Defense. He was off out to go and do some work, and just essentially became completely debilitated following a series of injections, about 5 in a period of 2 weeks, was it, Roman? Something like that, all of which contained aluminium. And we have been sort of looking at him ever since. The question, I have to sort of impersonalize this because I want to know, well, why? Could aluminium be involved in his condition? So he agreed for me to check whether or not he had more aluminium in his body than might be expected for someone of his age, gender, etc. And yes, we found that he did indeed have a very high body burden of aluminium. We don't know whether that body burden was before he had the injections or subsequent to the injections, because it was 3 years down the line before I got to see him. But his body burden of aluminium was coincident with the macrophagic myofasciitis, which you'll hear about later from Romain, and indeed with chronic fatigue syndrome, and indeed with a whole plethora of other conditions, some of which close to things like MS. This gentleman is still severely ill and more or less debilitated. He receives compensation from the UK government, who have agreed that his condition was caused by vaccination. That's all they agree, but that they do compensate him. Although there is no compensation, this man is more or less in a wheelchair. He's in his 40s. I ask this question because have we thought about this before? And this is true for any adjuvant. Is it only an adjuvant because it's in a vaccine at the site? Or can the same thing be an adjuvant anywhere in the body? Why can't it be? In the same way as the antacid might sensitize you to something you're eating along with it, can an accumulation of something, perhaps aluminium, somewhere in the body, have adjuvant activity wherever it may be found? Why does it only have to be when it's injected as a vaccination? There's no reason for that, is there? Its adjuvant activity can take place wherever it is. There will be provisos to that, but there is the potential for that. So, could you remind me what time I started? 20 minutes. Okay, so I'm very quickly going to say give you some idea of how we are all exposed to aluminium, such that we all have a body burden of aluminium. And incidentally, if we were to take each of us and dissolve us in nitric acid using a bit of microwave digestion and measure our total aluminium body content, we would have orders of magnitude between all of us. Indeed, if we were all to take a drink of aluminium now and measure then our production of aluminium in our urine, there would be an order of magnitude between the person absorbing the lowest and the person absorbing the highest. We know that there are in approximately 10% of the population, and we don't know why, who we call super absorbers, who absorb significantly more aluminium than anybody else. There are some groups that we know who do this. People with Alzheimer's disease absorb much more aluminium. People with Down syndrome absorb more aluminium. And we also know that you absorb more aluminium with age. Aging is a risk factor for aluminium absorption. We also know that when each of us die, it is very likely we will have more aluminium in our body than when we were born. In other words, we do accumulate aluminium in our body over time. Don't get me started on why that is, because then I'll run out of time and the story won't finish. So this is what we have to do. We have to have this balance between our exposure, the burden, and our excretion of aluminium to understand how much aluminium there is in us and where it is. The obvious one, perhaps, is in what we drink. So we are exposed both through the stomach, certainly through inhalation across the lungs and the nose. There's plenty of water vapor or anything of that sort which we're taking in and potentially can get inside of us in that way. I put a little question mark by the skin. We always believed, didn't we, that the skin is this impervious barrier, protects us from everything. You know, and we all poo-pooed the cosmetic companies that were producing all these compounds that said directly delivers to a particular site. And then nicotine patches came along, and everyone accepted that you could get nicotine across the skin by popping a nicotine patch on it. And many other examples now of the skin is not as impervious as we thought. And while I don't know, my guess is that if I did have a bath in alum salts instead of bath salts, I'm pretty confident that my next urine sample would have more aluminium in it than the one before. So the skin is not completely impervious to aluminium. In water, we know it's not impervious in other forms. Clearly what we eat, both directly through the gut and also sometimes parenterally, when food has to be injected, the contamination of parenteral solutions is well known. Even the FDA have tried to do something about that without a great deal of success, but they recognize that this is a real problem. People already susceptible for whatever reason, and that's why they're having to receive parenteral nutrition, are then being loaded with aluminium. Lovely. That's got to be a good thing. The absorption across the gut is limited. it must be less than 0.1%. It's probably 0.05% of the total aluminium that enters the gut. And for many, many years, people have thought that's the only way aluminium gets into the body. My personal opinion is now it's simply one way. It's no longer the only way, and I'm not even convinced it's the major way. Those of you who like to partake either in the legal or illegal forms of smoking, we're pleased to know that after you've had your cigarette or your spliff, that your next urine sample will have more aluminium in it than the one you had before. Yep, and Jesus would have been the same. And potentially the worrying thing about that is, of course, that you're taking that aluminium in your cigarette fumes either directly over the lung, which means that it doesn't have to go through the liver before it can go to your brain and other places, or indeed you're taking it through your olfactory system, which gives you direct access to the hippocampus without having to cross the blood-brain barrier. Now, it's no coincidence that on other recreational drugs that people take them through the nose because the hit is fast. It gets to the brain very, very quickly. So again, cocaine and heroin, you know, it's quite surreal working on heroin in the lab. And we actually had a little machine that smoked it, and we did chasing the dragon and all sorts of things. We couldn't tell anybody about it. Had to keep it completely. We had to have licenses, obviously, to do this. But heroin contains large amounts of aluminium. You know, people who die of heroin overdose in their 20s, we know they have all of the early signs of Alzheimer's disease in their 20s. Whether that's because they're also taking in aluminium, I don't know. But it could be an interesting coincidence. We all know about this one, and listen, I don't want to be unsociable, so I put it under my arms as well. Aluminium salts are the most effective antiperspirant known to man, and that is why they have persisted. The Unilever and all these companies that make them have desperately tried to find something else to replace the aluminium because they know deep down it's not good to have all that 1 gram of aluminium under each arm every morning. They know it's not good. They know because of people like Richard Flaren's work that some of that aluminium ends up in your urine sometime later. So we know we do absorb it across there. But hey, I'm still putting it there, so I don't know what the alternative is at the moment. And I do wash, by the way. There is so much aluminium in medications. Some of which, of course, you know, because it's an antacid, it's made of aluminium. But how many people know that your aspirin is full of aluminium, particularly anything that says buffered on it? Because aspirin is very poorly absorbed in the gut. If it hits pH 2, it really is very poorly absorbed. But if it hits pH 2, but you've also got a buffer in there, which can actually raise the pH up to about 4-ish, the absorption is potentiated. So that's why we now have some really fast, effective aspirins that work very quickly because of the buffering that aluminium salts give when they're given together. I'll give you a quick throwaway point. We're doing some work at the moment on the aluminium content of drugs for people with neurodegenerative diseases such as Alzheimer's, Parkinson's, and multiple sclerosis. Is there aluminium in those drugs? You bet. It may take us another 12 months to publish this and finish the work, but you bet there is. So we're giving people who essentially have diseases which could be related to aluminium exposure, we're giving them aluminium in their drugs. And for Alzheimer's disease, these are drugs that do no use anyway. Sunscreens, sun creams and sunblocks. I never use these things for many reasons. If I start talking about this now, and coincidence of melanoma and the use of sunscreens and this perfect curve that we've seen quite a few of, causal or not, they do contain large amounts of aluminium. Aluminium is a pro-oxidant. both the active UV barrier protector and the aluminium get into the lower areas of the skin where they can act together to produce a pro-oxidant effect. Whether that has anything to do with melanoma, I don't know. But it's there, and if you, one day on the beach, if you follow World Health Organization guidelines on these products, you will put about 5 grams of aluminium on your body. This is our latest work on baby feeds. Quite unbelievable, and almost more unbelievable that no one wants to do anything about it. So in the European Union, we can have 200 micrograms of aluminium per litre in our water, so that is a maximum level. I think it's probably the same in the States. 50 is the recommended amount, 50 micrograms per litre. These are not health-based things, but they're still legislated. And it's the only legislation for aluminium that exists, actually, with respect to human health. However, in baby feeds, you've got orders of magnitude more aluminium in every major baby feed that we looked at. And we looked at the 15 most popular baby feeds in the United Kingdom. And the one that had the highest amount of aluminium in it, nearly 1 milligram per litre, 5 times the amount that would be normally allowed at the maximum in water, was for preterm babies. Preterm babies.
How much?
Concentration? Nearly 1 milligram per litre. Of course, here we are in where we are today. So that is also exposure. And we also know from the work of Richard Florand that aluminium in adjuvants does appear in our urine. So we know that it does get all over the body. So, living in the aluminium age does ensure our body burden of aluminium. And our body burden is everywhere, but there are certain places where it's most likely to accumulate. So, for example, you rub your arm, you remove quite a few skin cells. In doing so, you slough off quite a lot of aluminium that's in those skin cells. In other words, any cell preparation which is turned over quite quickly, there is less chance for aluminium to accumulate. Those cells or tissues where they are not turned over quite so quickly, or not turned over at all, such as your neurons, these are obvious targets for the accumulation of aluminium. So the brain, the neurons, things like the bone, things like macrophages, things like heart cells, long-lived tissues and cells are obvious targets for an accumulation of aluminium. The question then arises, of course, now, probably one of the reasons why aluminium adjuvants are so effective is that they do initially, because it's quite a high concentration, you're putting in 0.5 mg of aluminium into a very small area of interstitial fluid, so that concentration initially is very high. You produce a localized effect which could then cascade as it gets diluted into the lymph, other interstitial fluids, the rest of the body. In other words, probably for adjuvants to work effectively, there is some sort of threshold. There is a threshold effect. Now that threshold effect can also apply anywhere in the body. So wherever you have an accumulation of aluminium which perhaps exceeds a threshold which is as yet unknown, then that accumulation of aluminium could act as an adjuvant and it could act as an antigen. How does that impact on our thinking and what we're thinking about today? I mean, I've just put this one up because the brain is an area that we're working on quite a lot, and we were recently invited to review aluminium in the human brain. We've been invited because we're actually doing the largest study of the aluminium content of human brain ever attempted at the moment, where we will probably manage to get about 100 human brains analyzed. We've done about 80 or so at the moment, and then our funding ran out actually in December, so we'll have to stop. But even 100 brains, looking at all 4 lobes, we're going to present some very exciting data on how much aluminium there is in the brain. But more importantly than how much is where is it? Because it's focal accumulations that really matter. Because those act both potentially as thresholds and also as sources for biologically reactive aluminium. This schematic is just to give you some example of how potentially complicated it is. And you know, politicians love using this word complex, so I try not to use it. Because actually, it might not be so complex. It's just that when you don't know, it does appear so. I think when we do know, it will be relatively simple. I know that sounds like a bit of a paradox in itself, but I think that is the case. It's only our lack of knowledge which makes this look complicated. Here is an example of an accumulation of aluminium in a human brain. What we've actually got here is a plaque which is about getting on for 70, 80 microns across. And the area that's stained bluish purple shows the presence of aluminium. The area stained red shows the presence of a protein called beta amyloid, which is implicated in Alzheimer's disease. But I show this particular picture only as this could be, for example, sitting in the brain. This could surpass a threshold for aluminium being an adjuvant and or antigen in the brain. Just imagine you have a higher than normal body burden of aluminium. You are potentially accumulating it in certain areas in the body. You then receive multiple vaccinations, all of which contain some aluminium. In those multiple vaccinations, aluminium is acting as adjuvant and antigen. It sets off cascades of potential responses, which I believe potentially can then cascade around the body, setting off potentially other stores of aluminium, whether they be in the brain or the bone, the connective tissue, the places where we might expect to find high or raised levels of aluminium. Could this type of cascade effect explain why an aluminium adjuvant could then, in some individuals only, produce such adverse effects and such generalized adverse effects? And many of the adverse effects that you see in people who have suffered following vaccination are very similar to the known effects of aluminium intoxication. So we do have situations of aluminium intoxication, and we do see many similar effects, such as the chronic fatigue, the muscle spasms, many things that aluminium is known to produce. This is the paper available online, but I don't quite have all the rest of the details yet. Anyway, there's some good news. Even if what I said was bad news, there is still some good news. The good news is that, of course, we have the excretion side of things. We are pretty damn good at keeping aluminium out of our body, but we don't manage it. However, the urine could well save us. We have fridges full of human urine. It's not so bad when it's cold. It's working with it when it's got back to room temperature that people object to. I have one student, she's doing an absolutely fantastic job. I'll show you a little bit of her work in a second, who has done this for 3 years. And what a challenge that is, working with human urine for 3 years. She's working on human urine for 3 years because a few years ago we published a paper which showed a very simple way to get aluminium out of human beings. If you give them a mineral water which is rich in silicon, rich in something called silicic acid, SiOH4, the biologically available form of silicon, they pee aluminium in their urine. You can titrate aluminium from your body with a silicon-rich mineral water. And in this case, we were able to show we could do so in people with Alzheimer's disease. We now have programs up and running for healthy volunteers, people in their 20s. We have a program up and running for Alzheimer's disease where we're extending the period of time over which they are taking the silicon-rich mineral water to around 13 weeks. And we're just starting a program for Parkinson's disease. Again, without I'm not giving anything away by telling you that we are going to be and have already been successful in removing aluminium from all of these types of people by simply giving you something you can buy on the supermarket shelf. I'm going to break all protocol and tell you that the one water that works incredibly well was a water called Volvic in the United Kingdom, made by a French company called Volvic, made by a French company called Danone. But I can't tell you that now, because since Danone went into an agreement with us to work in this area, they then told me they no longer want to work with us. They no longer want to be associated with the possibility that aluminium, removal of aluminium might be an important thing. They will benefit from it at some point, because they are one of the few companies that have a silicon-rich mineral water. The one that we work with as well is a company called Spritzer, who will be more than happy for me to mention them in Asia, based in Malaysia. And their mineral water is even more effective than Volvic. It contains even more silicon. There are no downsides to silicon. Silicon is good. Silicic acid, SiOH4, is good. I haven't got time to tell you why, but believe you me, it is. And here's a quick snapshot. This is just one individual. All we really need to see, we've got excretion of silicon in the urine. That's the black. We've got excretion of aluminium and other metals in the urine. The aluminium is the red. Against time for an individual having drunk a silicon-rich mineral water. I think we can all see that the aluminium and the silicon come out together. We have this for about 25 healthy controls, males and females now. It's very difficult data to do sort of stats on. You're not sure whether you're going to do it on single individual, you're going to try and put it all together, because everybody's physiology is different. So we're working on that. So I'm just showing you one example. But we know that you drink a silicon-rich mineral water, you pee aluminium. It's absolutely, I'm absolutely confident if you included a silicon-rich mineral water in your everyday diet, that most of us could get our aluminium contents down to as close to, inverted commas, normal as possible. Like many of you, I am contacted on a regular basis by people who have been adversely affected, sometimes by vaccination, and other aluminium-related issues. I have been contacted by parents of girls who have taken the human papillomavirus vaccination, and they have said, is there anything we can do? Is it got anything to do with aluminium? I don't tell them it's got anything to do with aluminium. That's not my role. I am not a doctor. I would simply tell them, look, if there is anything to do with aluminium, try taking a silicon-rich mineral water. I tell them which one. I am increasingly getting emails back 6 months, a year later. They're telling me that their daughter is better. I'm not making this up. Their daughter is better. I say, well, it might have had something to do with that. It might just be something else that you're doing, but that's great news. So anecdotally, at least, we're getting good results here. We need, of course, to get proper scientific data as well for people potentially getting better simply by drinking a silicon-rich mineral water. Thank you very much.